There was a question today from a student about some of the problems that you have for homework tonight. So I thought I'd run through one of them. This is problem 23. I think it's on page 289. And the directions for this problem, which is on the previous page, say tell whether each relationship represents a direct or inverse proportion. So let's kind of review that before we start. Direct or inverse proportion. So we know that a direct proportion is in the form y equals kx or y divided by k, x equals k. In an inverse relationship, we know that x times y equals k or y equals k divided by x. So we are looking to see if the relationship in the problem has two variables that look like or can be arranged into one of these types of equations. So here we have in our equation, we have 3 equals m divided by v. Now, we have a form of an equation here that shows an output variable divided by an input variable. So it says the density of a substance is the mass of the substance per unit of volume. A particular substance with a mass m grams and a volume of v cubic centimeters has a density of 3 grams per cubic centimeter. An equation for the density is 3 equals m divided by v. So 3 equals m divided by v tells us that we would have, even though it's on opposite sides, we would have a relationship that we can see is already here. And even if we want, we can multiply both sides by v, and we're going to get m equals 3 times v. So in both forms that we can put this equation, we see this as a direct relationship. Now let's see if it makes sense. So we have the density of a substance is the mass of the substance per unit volume. So what we're saying is a particular substance with a mass of m grams and a volume of v cubic centimeters has a density of 3 grams per cubic centimeter. So what we're trying to figure out is whether or not mass and volume increase together. And they are written in a ratio. So in order for them to continuously equal to 3, as one goes up, the other is going to have to go up with it. So this is what makes this a direct proportional relationship. So in these kinds of problems, and we'll go over them in class, take a look at whether or not the information you're given follows a direct or inverse proportional relationship in the equations and the way they are written. I hope this helps.